All right, in section 2.4, we're going to start our discussion on how to find zeros of polynomial functions. And we're going to start our discussion by talking about real zeros. And then in section 2.5, we'll discuss complex or imaginary zeros. But before we get there, we need to discuss different ways of finding remainders whenever we divide a polynomial by another polynomial. And this is a skill that you'll need for your AP Calculus class. And so in example 1, I'm going to long divide 2x to the fourth minus 3x cubed plus 5x minus 1 by x minus 2. And I'm going to do this using long division. And I understand that this is not always necessarily the fun thing to do, but we have to be able to do it in certain scenarios. And so for long division, we're going to take the denominator, x minus 2. That's going to go on the outside of a division box here, and we are going to put the numerator on the inside. Now, one thing you need to be very careful of is to notice if any terms are missing. And so right now I notice there is no x squared term, which means I need to put a little placeholder here, 0x squared. And if you don't do that, it's going to be really difficult to keep things lined up and organized the way you want to do them. Okay, so we are going to do this just like we did in elementary school when we divided numbers. We're just dividing polynomials here, and so that's what we're going to do. So I'm going to start with this lead term here, 2x to the fourth, and I'm going to divide it by the lead term here, which is x, and 2x to the fourth divided by an x is 2x cubed, and I am going to put that right above my x cubed term. After I divide, I'm going to multiply. So this 2x cubed here is going to get multiplied by this x minus 2. And so it's basically a distribution process. 2x cubed times x is 2x to the fourth. And then 2x cubed times negative 2 is going to be minus 4x cubed. So let's erase that 2. And let's get a 4 in there like we're supposed to have. There we go. And then the next thing we want to do is subtract. And so I'm going to take another color here. I'm going to put a minus sign and change this minus to a plus. So essentially what I'm doing, and this is the way that I explain it, and I've explained it this way for years, is I change the sign and then I combine the terms. And so 2x to the fourth and negative 2x to the fourth are going to cancel. And if you're doing everything correctly, that first term is always going to cancel whenever you change the signs and add. And then negative 3 and positive 4 will give me positive 1x cubed. And then I'm going to drop the next item down to the last line. And then I'm going to start the process all over. So I'm going to say, okay, well, what is x cubed divided by x? And x cubed divided by x is x squared. And that's going to go above my x squared term, which again, you see why it's really important to have things lined up correctly. After I divide, I'm going to multiply, so x squared times x is going to give me x to the third, and x squared times negative 2 is going to give me minus 2x squared. I'm then going to change the signs of that last line to negative and positive, and I'm going to combine the terms. And so these x cubes are going to cancel. I'm going to get positive 2x squared, and then drop down the next item here, which is a plus 5x. I'm now going to divide again, so 2x squared, the lead term here, divided by the lead term here, which is x, and 2x squared divided by x is going to give me 2x. And then multiply 2x times x minus 2, so that will be 2x squared minus 4x. And I'm running out of room, which is a little unfortunate, so I might just have to kind of come over here and continue. But the next thing I would do is change the signs and then add. And so using my red here, I would change that to a minus, change that to a plus, and that's going to give me 9x whenever I combine those. 2x squared is going to cancel, and so I'm going to have 9x, and then I'm going to drop down the next thing, which is minus 1. And then I'm going to divide one more time. So 9x and divided by x is going to give me plus 9. And then multiplying will give me 9x, subtract 18, change the signs to minus and plus, and then add one more time, which is going to give me 17. And 17 is the stopping place for a couple of reasons. The first reason is because I'm out of space up here. There are no more slots to put any terms. And so that's one way I know. And then the other way I know that I'm finished is the fact that I cannot divide 17 by x. And so here's how I'm going to write the answer whenever I long divide. We start with the quotient, which is what is on top of our division up here. So I'm going to start by writing 2x cubed plus x squared plus 2x plus 9, and then go with your remainder. And so my remainder is this number right here. This is called the remainder. And so I'm going to add the remainder, and then I'm going to divide by what I divided by. And what I divided by was x minus 2, and you can see that right here also. And so the denominator of that 17 is going to be x minus 2. And so here's my answer using long division. Now, if you're exhausted from that last example and just totally over this already, the good news is that a lot of the times we're going to be able to use synthetic division, which is much, much faster. So as long as you are dividing by a term that looks like it is linear, x minus c or x plus c, you can also use synthetic division. And your Algebra 2 teacher might have shown you just a different way to write this. And so if they did, I apologize, but this is the way that I've always done it and the way that I learned. And so I don't think it's going to be a ton different than what you possibly learned, but there's a possibility that it will be. So synthetic division, I need to know what number to divide by. And so the way to know that is by looking at the denominator here, x minus 2, and setting it equal to 0. And in this case, I get x is equal to 2. So I'm going to put 2 in a little box here, and then list the coefficients of the numerator. And so starting with x to the 4th, that's a 2. X cubed is negative 3. Remember that there was no x squared term, so I've got to put a 0 there as a placeholder. 5x, and then minus 1. And then leave a little bit of space and put a horizontal line. I like to also draw a little vertical line down here because I know that the last number is always going to be my remainder. And if you'll notice, this is the same problem that we did in example 1. So the goal here is if we do it right, we should get 17 just like we did before. Okay, so first step in synthetic division, I'm going to drop down the first number, and so the 2 just drops down to the last line. I am then going to multiply the number on the last line by the number that's in my box here. And so 2 times 2 is 4, and 4 is going to go in the next column directly below the negative 3. So you see why I needed the space there when I drew my horizontal line. And then I'm going to add that column. And so negative 3 plus 4 is going to give me 1. And now I'm going to repeat the process. The only thing I'm never going to do again is just drop a number straight down like I did to start this whole thing. So here now I'm going to take 1, I'm going to multiply it by 2, and that's going to give me 2. Add it to the 0, and that's going to give me 2. 2 times 2 now, so this 2 on the last line times this 2 here is going to give me 4. Adding that column is going to give me 9, and 9 times 2 is 18, plus negative 1 is the same remainder that I got before of 17. Now, how do I write my answer? Because right now on the last line, I just have a bunch of numbers. Well, this top line started with x to the 4th. When I divided that first time, I divided by a term that had x, and so that gets me down to a line that starts with x to the 3rd. And so this is going to say 2x to the 3rd plus 1x squared plus 2x plus 9, and then plus my remainder divided by what I divided by. And you can check this with your answer from example 1. It should be exactly the same, and it was much faster because we used synthetic division. And just as a fun fact, the reason it's called synthetic division, if you know what the word synthetic means, it means essentially fake. And so what this is this is fake division because I never actually divided anything. I was multiplying and adding the whole time, and it just so happened that it led to the same answer as when I long divided in example 1. Now, example 1 was tough. Example 2 was a little bit better, but if it still exhausted you, get ready, because example 3 is way faster even than example 2. So we want to evaluate f of 2. Notice that 2 is the number that we divided by in example 2. It was the number that we put in our box when we used synthetic division. And let's see what we can figure out from this evaluation of f of 2. So f of 2 is going to equal to 2 times 2 to the 4th minus 3 times 2 cubed, just plugging in 2 for x. Instead of x, I'm going to put a 2, minus 1. Now, if you have a calculator, you could just type this straight in. I don't have a calculator, so I'm going to have to do this by hand. And so this is going to be 24 plus 10 minus 1. And so 32 minus 24 is 8, plus 10 is 18, minus 1 is 17. Now, what do you notice about that number? Yes, that is the remainder that we got in example 1 and example 2. And so a shortcut for finding the remainder, if that's all you want to do is find the remainder, all you have to do is just evaluate the function at that particular 0. And so that's the fastest way to do it right there, is by using the remainder theorem. And so the remainder theorem says that if a polynomial is divided by x minus c, then the remainder is the same as the function value f of c. And so all you have to do is plug in that number that you would synthetic divide by, and the corresponding answer will tell you what the remainder is. Okay, so just to summarize what we've done so far, when I divide a polynomial by x minus c, I can find the remainder using 3 different methods. The first one would be long division. That's probably my least favorite, but I do need to know how to do it, because in calculus sometimes I do have to divide by things that are not linear. The second option is synthetic division, which is a little better. Still not super fast, but it is definitely faster than long division. And then finally, letter C, definitely the best option is that remainder theorem, where all you have to do is plug in C to the function and get your remainder for free.